Hi everybody. All right. So in this lesson, what we're going to do is teach the robot to stop where we want it to stop. So let's take a look at the challenge here. We're in the line following maze that we did last time. If you don't know how to get to that, you just come up to the hidden menu, click here, click on Sim Basics, and it's the top row on the end here, maze. There we go. All right. So what I did next was I take that robot and make sure that it has all the parts on it that it needs. I'm going to remove everything and show you how that works. So color sensor 1, I'm going to put on the front left. It's important to remember to remove the one in the center and add these on the front because the default robot has one in the center and we actually need two to do what we're going to do today. So I'll put the color sensor 1 on there and click add. That's important. Put color sensor 2 on the other side, hit add. All right, so I've got two sensors there. I hit OK. The next major thing that I need to know is what port are those sensors attached to on the robot. Easiest way to find that out is to go to port view on the virtual brick. So you might need to connect to the robot here and then go to port view. And when you go to port view, the Virtual Robotics Toolkit is going to go into a mode where you can drive the robot. Hit the W, A, S, and D keys and park one of the sensors over the dark line and the other one on the board. So I know that the sensor on the right is port number 1, and I know that the sensor on the left is on port number 3. So now I've got all the information that I need to write an algorithm to get this going. So last time we talked about a very simple line following algorithm, and I'm going to show you more how to use it this time. So to go back over that line following algorithm, it was a switch-based system that had two states. Whoops, what am I doing? There we go. That had two states that are compared. Now, our goal in this one is to come up to this line here and detect this intersection. This is what we're trying to do, detecting this intersection and making the decision that we want the robot to make. So because this intersection is on the left, the robot will be here and this intersection will be on the left. What that means is we need this sensor, the robot's right-hand sensor, to follow the line, and this sensor is used only to detect that intersecting line. Now, if you'll recall, this sensor is port number 1, so we need to make sure that our line following algorithm is using port number 1. That is a very common mistake, but I think you can avoid it by going along with this. All right, so now I'm going to put a couple of move blocks in the top. I'm going to turn them on. We went over the basics of this last time. There we go. And I'm going to make the one on the left, let's say we'll make it positive and 50. Somewhere around there. It doesn't matter if you're exactly on the right spot. And we'll make this one negative 50. All right. Now, when you first start the robot out, it's actually on this green little pad. So the first thing that we really need to have the robot do is just drive forward a little bit so that it can get onto the black line. So I just grabbed a move steering block, put it there, told it to go for one rotation. Then it will launch into this loop. So first thing we need to do, well, let's take a look and make sure that that's working for us. Yep. Okay. If I right click and hold, I can keep the board stable while the robot goes, so I can see the moving. If I let go of it, it follows the robot so that your camera is always able to see the robot. So you can kind of choose which way you want that to work as you're experimenting. So our robot is fine. It did not stop at the intersection because we haven't told it to, and it took the path on the right. So here is the big piece that I want to go over today. I'm going to cancel this. There we go. All right. Now, in this loop, what we need to do is click on the unlimited here. We are going to limit that loop. We're going to give it a limit. And what we're going to say is, I want you to see, I want you to see this intersection over here. I want you to see this intersection with the sensor that is on port 3. So what do we know is going to happen when that sensor crosses this line? The reflected light value is going to drop for sensor number 3. All right, so I'm going to go to the unlimited and I'm going to change it and say I want you to end this loop. That's what this section is about. When you want to end this loop, I want to end it when the color sensor's reflected light intensity on port number 3 is less than 10, because these lines are perfectly black in this particular simulation. All right, so if I do that, now I can hit go, and let's see what happens. Robot's following the line nicely. All right, here it comes. Boom, the robot stopped right there. Now, this is an important point right here. The program is completely stopped running. It has exited. Now, this position, we always will know that the right-hand sensor is going to be on the edge of this line, and the left-hand sensor is going to be on top of this black line whenever we run this. So from here, we can actually tell the robot to make a decision. So for instance, if I want it to go straight and continue its progress, here's how I would do it. I would give it a little forward. Let's say a 0.2 drive forward. And then I would just copy this and paste it. I hit Control C, Control V, just like you would with text, and boom, I have that. So now I have drive out of the box, go until you get to the intersection, detect the intersection, drive past the intersection, and then keep following the line. And if I do this, it's going to choose to go straight. So let's see if it does. I'm going to reset the entire simulation and hit play. Here we go up to the intersection. It's going to detect it, drive forward a touch, and then go along its merry way, continuing to go straight. This is how, on a WRO board, you get the robot to sort of ignore an intersection. That's how you get it to ignore it. Now, what if we don't want it to ignore it? I'm going to delete the blocks that I added there, and I'm going to run this so that we can think about what we want it to do when it gets up there. All right, here comes our robot. And I'm going to do this. I'm not going to cut here, so I may make some mistakes, but I want you to see the mistakes I make if I make them. All right, so here is where our robot is. As I said earlier, the left sensor is over this line, and the right sensor is on the edge of this line. We know that the robot will be in this position. So if I want the robot to make a left turn, I have to add to my algorithm now, and I add it from where it is right now. So I like to actually run the software, get the robot into the position, and then I like to add another piece of instruction and run just that piece to see how it's going to work. In this case, I'm going to tell the robot to do a left turn fully at point, let's say 6. I'm almost guessing here. This is going to be guess and check type stuff. I'm going to run this, and I'm not going to edit it out if it fails, because I want you to see what this process is like of this checking and seeing how everything works. So now watch this. You can do something interesting here. I'm going to run just this block. So I clicked on the block and it's now selected, and I can come down here to this third thing and hit run selected. All right, so when I did that, the robot rotated to this, and actually I think I may have gotten it about right. So if I know that my robot's going to be in this position after doing this, you know what? Before I move any further, I should run it and make sure that that's what it actually does from the beginning. Here we go. It looks good. Let's take a look. All right, so the robot's going to come up and follow the line. Here we are. Comes to the intersection. Notices it and turns. Yeah, it did a pretty good job there. And this right sensor is on top of this black line again. So what I was trying to say about guessing and checking it, I didn't know I was going to get it right. If you had guessed, like, let's say not enough to get the robot on the line, let's say you had done 0.2 instead. Then you would just take a look at the result after you run it and then modify that result. But the key point here is try to change only one thing at a time. Try not to get ahead of yourself and do a whole lot of different things at the same time. All right, so if I had written it wrong and I had done this, I would have needed to have gone back and changed this to be a little bit more distance, right? And I would guess and check until I got to 0.6. But I know that this algorithm is correct and that when I run it, the robot's going to be in about something like this position. All right, so what's next? I would run this piece of line following software. Again, Control-C, click, Control-V. That's all I'm doing, putting it there. Let's run that and see what we do here, what we get. Once again, I'm not gonna edit out if there are any mistakes. Here's the intersection. And we're wanting to see it take a left turn. There it goes. So we got the robot to take the left turn the way we wanted to. And oh, look at this. Okay, so now I have a problem. The problem is in this curve, the robot did not turn sharp enough in order to avoid this sensor hitting the line. So that means in this second set here, I probably need to make this a tighter turn like this. So let's take a look and see if that helps. Oh, okay, so making it so tight means that I need to change this. So I'm going to go back and I'm going to edit one piece at a time. So what do I know? I know how it gets to here. So I broke off this part of the code, but I have not deleted it. I just moved it off. Now I'm going to hit play. I'm going to go through this process. And this process of going back and changing one piece at a time, this is how you get to an ultimate solution. You don't just sit down and write it once. It comes over a period of time. All right, so here, it looks like what I need to do is maybe make this a slightly less steep curve. Let's try it at -66 instead of there, maybe. And that'll leave my sensor here to the right. And therefore, it'll be too bright and it will turn left. Yeah, let's try this. Let's try this. So now I'm going to go back. I'm going to hit stop. I'm going to go again. And I'm going to try it with this modification. So I'm just trying this to try to get the robot to where I know for a fact when I run this loop, it's going to see it. Everything's going to be set up for it. Yeah, okay. All right, that looks good. I'm going to add this loop and see if altogether it's doing any better. And I also wanted to add that I would really like to emphasize the importance of letting people see when things don't go well when you're programming, because most of programming... look, so I have to go another little bit to the left because this is on the line. It exited the loop out here. So I've got to make sure that I go far enough to get this off of this line. So I'm going to go a little further with this. Let's say 0.7, and I'm going to run that. But it is important, as I was saying, to let people see when you make mistakes. When we look at YouTube videos of WRO challenges, frequently there are people who are having a perfect run and it took them 35 seconds to get the robot to make the run, and people think, oh my gosh, I could never do that. The thing is, it's not that bad. It's just a process that you need to go through. I'm going to go ahead and increase this even more to, let's say, 1 full rotation and see what it does. That way, well, so the point is that you just have to keep working on it and change one thing at a time. Those runs that take 35 seconds are the end result of weeks of work, often, of just going through one piece at a time like this. This is the process that you use to get those results. Let people see the process. I think that will make us all better roboticists in the end. All right, I'm almost there. I need to get it to turn just a little bit left more so that I can get this one on there. I'm going to make this go all the way to a 1.3. And ordinarily, this video is going to go long, and I'm just going to let it go long because I want people to see that perfect solutions, these solutions take a while. Yep, okay. Now let's see if our extremely ziggy-zaggy robot will help us prevent the problem that was in the bend that we had. Yep. There we go. It's a solution. All right. So I hope you guys enjoy the process. My challenge for you now is you've got this basic algorithm that you can see right here. Here, I'm going to maximize this algorithm so you can just see it, and I'll zoom in case you want to take a look at it. Now, line racing is a thing that I think we're going to do. So the thing about line racing is you got to make this as accurate as you can. And this is just one method of following a line. So your challenge for this is if you're new to line following, edit this and make it work as fast as you can. There are different ways that you can do that. You can mess with the speed of the algorithm. You can mess with how much it turns. You can change what speed these do. That will help you with speed. You can change how hard these turn. See if you can tune this in to get a faster amount of time to get it going faster and smoother than I did. And next time we'll talk about proportional line followers, which are a way to sort of make a computer do some of these calculations for you. So until I see you then, have fun and happy coding.